Okay, we're here at go2math.com working some calculus. We're in the numerical approach section, and that's actually, I'm trying to get 2.2 to come up, and there it is. Okay, got three of them in this particular section here. Alright, so we want to evaluate this limit numerically. Alright, so let's move over to the whiteboard. So we have the limit as x approaches 7 of 36x squared minus 1, and that's all over 6x minus 1. Now I'm going to write this as a function here. We got 36x squared minus 1 over 6x minus 1. And what we're going to do now is I'm going to factor this thing, and you know, this is something that we do big time in the next section here, so that's kind of the reason I'm doing it. We can actually write this as 6x minus 1, and I don't know if I've stated this or not, but you see this right here? This is a difference of two squares. All right, and then we have 6x minus 1. So difference of two squares, we can write this as 6x minus 1, and then 6x plus 1. And then it's all over 6x minus 1. Now, it's not necessary to go through all this to actually determine this right here, but we're doing a little extra, okay? Something a little extra. And I'm also going to, we're going to draw a picture with this. You know, a lot of what we do in calculus, we can draw pictures too, so, and that kind of sticks in our brain. Let's let this be 1/6. That's an interesting point, and we'll say that's 7 right there. Okay. Once we can cancel these two guys out and rewrite this function as f of x is equal to 6x plus 1. Now these are two different functions here. These are two different f's. But if we state this, that x cannot be equal to, let's see, what makes the denominator 0? 1/6. So x cannot be equal to 1/6. That was the reason I wrote that there. Now these are both the same, even though they don't look the same, but they're both the same. Okay? As long as we state this right here, that x cannot be equal to 1/6. In other words, we got to throw that out of the domain of this function here. Now we can say they're both equal. Now let's take a look at the graph of these guys, 6x plus 1. So it's cross at 1, it's got a slope of 6. I got a hole in the graph right here because at 1/6 it's undefined. Right? We can't use that number in the domain. However, in this problem we are approaching 7, but I am throwing this 1/6 in right here. Okay? So this is really what we're focusing on when we're trying to find this limit. Alright, and the way this works is we're going to come in from the left hand side, we're going to come in from the right hand side. What exactly does that mean? Well, what it means is we're going to do this. We're going to 7 minus 0.1, which is actually, this can be rewritten as f of, what is that, 6.9? Right, and determining that number, and then looking at 7 minus 0.01, and so that'd be f of 6.99. So what's happening is we're getting closer and closer to 7 coming in from the left hand side, and we're seeing what this guy, because this is what's important right here, this number right here, right, this y value that's paired up with this. Okay, so I've got a dot right here on the map. And so that's what we're really looking at. We're getting closer and closer and closer to 7 coming in from the left hand side, and we're seeing what this number is actually getting closer and closer to. Okay, then we do that on the right hand side. So come in from the right hand side, 7 plus 0.1, which is really f of 7.1, and that means you take 7.1 and plug it into this up here, okay? And then get that number out, and then we can look at 7 plus 0.01, which is f of 7.01. So as you can see here, we're getting closer and closer coming in from the right hand side, and and seeing what our y value is getting closer to. Now this guy is going to converge towards a number, and so is this one, and if both of these numbers are the same, they're converging towards, then we can say that this limit exists and it's equal to whatever that number is. Now of course the big difference between f and the limit here, the limit tells you what it approaches. This function, we plug a number into it, gives you the exact value. The limit tells us where it is approaching. It's all about the approach, okay, what it's approaching towards. This guy only evaluates at a single point. For example, 1/6, if we plugged it in up here, it breaks down, right? Or I should say here, plug it in here, I mean, it totally breaks down. I mean, it doesn't tell you where that hole is at, but we can ask the limit to tell us where the hole is, where is this hole, or actually where's this point right here. Okay, so let's go back to the web page, and I'm going to hit help on this and see what it says. So we're approaching 7 coming in from the left hand side, right? 7 minus 0.1 is 42, 7 minus 0.01. So you can kind of see we got 42.4, 42.9, 42.99. So we can conclude here where this number is actually going, and it looks to me like it's heading towards 43 as we get closer and closer to 7 coming in from the left. And if we come in from the right hand side, we got 7 plus 0.1, right, which is actually 7.1. And as you can see, we have 43.5, 43.6, right, 43.006. So as you can see here, it's getting closer and closer to 43 coming in from the right hand side. So therefore, I'm going to bet that this thing is probably 43. Let's hit the answer there, and of course there it is. So there's nothing to it, just get some numbers, plug it into the left, plug it into the right, and if both those numbers look like they're converging towards the same number, then we know that limit exists, and we can pretty much determine what that number actually is. Alright, so we will see you back here at gotomath.com.